So today's lesson will be on metals, semi-metals, and non-metals. In this series, we're looking at classifying elements. This is one of the ways that we can actually classify elements into different categories. Some of these may be obvious, metals and non-metals. They may be obvious to you already, but we're going to look at them in sort of a more rigorous way instead of just the intuitive way that we're used to seeing. So first, before we talk about categorizing things, we just need to make sure that we understand how we categorize things. We basically categorize different elements based on their physical properties. Now, a physical property is anything that can be tested without actually changing the composition of the sample. So for instance, if I had a piece of magnesium, I wanted to test its malleability, I could bend it. Now that doesn't change what's in that piece of magnesium. It's still magnesium, but I can bend it to see how malleable it is, or I can hit it to see how flexible it is, things like that. So it doesn't change what's inside the sample, it just may change the shape or something like that. So physical properties can include electrical conductivity. So if I connected battery to it, I could watch how much electricity goes through it. Hardness, so if I had some kind of hardness scale, I could test how hard this piece of magnesium is. And you see, none of these things are changing the fact that it's magnesium. We're just looking at what it can do in terms of how hard it is or how conductive it is. Ductility, so if I wanted to draw it into a wire, I could, and it would still be magnesium. I could melt it or boil it, but that doesn't change the fact that it's magnesium. So you can see that these physical properties are just simply things that I can test without having to change the chemistry of the sample. Now, chemical properties would require me to change the sample completely. Another one is malleability. If I wanted to, hit it into certain shapes, I could do that as well. So metals, we all understand what a metal is. We've seen it. We can kind of picture it. But if you were to try and describe it to someone who's never heard of a metal before, I'd probably use these kind of criteria. So a metal is usually quite dense, okay? They have quite high density. So if I had a centimeter cubed of lead, it would weigh quite a lot compared to a centimeter cubed worth of air. So you can see metals are very dense compared to gases. Often, they're good conductors of heat and electricity. If you wanted to, say, show someone who's never seen a metal before, can conduct heat very well. Let's assume they know what heat is. So you could put your piece of metal in the fridge, an hour later, bring it out, and they could touch it, and they could feel how cold it was because it's such a good conductor of heat. That can be one way to describe them. Often they're malleable or ductile, so we can bend them and turn them into different shapes. Or we can draw it out into a wire, which is what we do when we want to build wires for electrical purposes. And this is probably the one that you'd start off with if you were to describe them. They're shiny, they're lustrous. You can actually, when you hold a piece of metal, it's usually shiny, it's quite nice looking, and that's probably how I would describe it first to someone that's never seen a metal before. I'd say, it's a shiny block of substance, and it has all these other properties as well. They have relatively high melting and boiling points, so it's hard to melt them. It's also hard to boil them equally. So with non-metals is one of those things that we kind of know. We just experience gases all the time. We breathe them in and things. But non-metals are actually quite a broad category because we can see them. We can actually find non-metals as solids, liquids, or gases. So we can actually find non-metal substances as solids. And one example of that is in this picture here. So on the very right-hand side, you can see that very dark crystal shape is actually iodine, and iodine is a non-metal. You can see that some non-metals actually can exist in solid form, and so that makes it a little bit more difficult to describe fully what a non-metal is. But what we'll find is, in general, non-metals have the following properties. Typically, non-metals kind of share these properties. Not all of them will, but most of them do. So non-metals have a variable state and form. Non-metals in general can be gases, solids, or liquids. Doesn't matter. For example, oxygen is a gas at room temperature and pressure, bromine is a liquid, and sulfur can be a solid. So we can see all these different chemicals can be different phases, different states as well. Now often they're not lustrous, so I don't see a shiny piece of oxygen all the time, nor have I ever seen a shiny piece of sulfur. They're usually crystal, or they can't be polished to very shiny look. Now this is probably the key one. They're really poor conductors of heat and electricity, with the exception of carbon in the form of graphite. Okay, so the graphite in your pencil, that's probably the only exception of this rule. It happens to be a non-metal, but it also conducts electricity really well. So it's just an exception. In general, you'll find that these non-metals are poor conductors of heat and electricity. So for instance, lightning, it's several thousand, or actually several million volts between the cloud and the earth. The current is very big, but it takes that several million. In order to get a similar current in a metal, you would need a much smaller voltage. And the reason is because the resistance of the air is so big, because it conducts electricity so poorly. Now in terms of the heat, what we find is that if you put a very small layer of gas in between two pieces of glass, so if this is glass here and this is glass here, and then you seal this section and put, say, air here, That makes the glass really good at stopping heat from escaping or getting in, and we call that double glazing. This isn't popular because it's hot here. It's slightly more expensive than a regular window. In countries like Canada, where it's very cold, triple glazing, so having another piece of glass here with more air in between, is the standard. So it's it makes the window much better at letting heat stay in a building. That shows you that air conducts heat very badly because the heat can't get out of this room into the outside world. Now, another property is that they're not malleable or ductile, and they're often brittle. A gas cannot be malleable. It's sort of infinitely malleable, but it won't keep its shape. So that's why we don't call them malleable or ductile. If we do find them in solid form, often we'll find non-metals to be brittle. So if you hit it with a hammer, it'll shatter. Whereas if I hit a piece of steel with a hammer, it's either gonna just bounce off harmlessly or it's gonna bend the metal a little bit. So they're not malleable at all. The gas, liquid, or solid phase problem, they can have lots of different types of melting points. The semi-metal here is not actually the shell or the rock, it's the sand. But semi-metals have properties of metals and non-metals. That's why we call them semi-metals. They sit in between. Their conductivities can vary considerably with temperature. So if I take silicon, bad conductor of electricity, pure silicon. If I heat the silicon, it becomes a better conductor. I continue to heat it, it gets better and better and better as I heat it. With semi-metals, the conductivity of the substance goes up as the temperature goes up. However, with metals, if you heat the metal and try to put electricity through it, it's harder to get the electricity through than if you let the metal become cold. So it goes the opposite way for metals and semi-metals. Now the conductivity, while it varies with temperature, it can also be changed if you mix semi-metals with other elements. So if you actually purposely contaminate your pure semi-metal with, say, boron or arsenic, we can actually improve the conductivity of the substance, okay? And we call that doping. That's how the whole semiconductor industry, computer chip makers, memory chip makers like RAM makers, SSD makers. So all of these computer chips are made by putting impurities into silicon and then using that to create logic gates and things like that for our computers. So that's how we make computer chips, by doping this silicon, which is a semi-metal, with these different chemicals. And generally they have high boiling and melting points. They're usually brittle. So semi-metals have very, very high melting and boiling points, and usually they're brittle, but not always. So that concludes today's lesson on metals, non-metals, and semi-metals. We looked at the physical properties of each of these, sort of what their applications are. So we'll move on to the question segment, and hopefully we can utilize this information to answer some questions. So which of the following groups contains only non-metal elements? So we're looking for only non-metals. The fastest way to do this would be look for the ones that have metals. So this one has palladium, and if you've watched the Iron Man movies, the little arc reactor in his chest uses palladium. We know that's a metal. A is definitely not one. Here we have iodine, nitrogen, and helium, and carbon. Now all of those are non-metals, but we'll have a look and see if we can find any other ones. Selenium, yeah, which is a semi-metal. Can't use this one. It has silver, Ag. And silver is obviously a metal, so that can't be that one. So it's probably B. It has iodine, which is a non-metal, nitrogen, which is a non-metal, helium, we know when we breathe it in, it's a non-metal, and carbon, as we mentioned, is a non-metal as well. So you're given a sample of the element iodine in a crystal form. Which of the following characteristics would it not have? Okay, so which one don't we see if we have solid iodine? Now, firstly, we need to know what iodine is, and iodine is a non-metal. Instantly, we can see that C, it won't have good electrical conductivity, because we know non-metals don't have good electrical conductivity. There you have it. Distinguish between the term physical and chemical property. So physical properties are those that can be found by studying the substance itself rather than the reactions it undergoes. Physical properties are found by looking at the substance and doing things just to the substance, but not looking at the reactions within that substance. Chemical properties describe how a substance reacts. So whether it reacts with water, oxygen, acids, and if it decomposes when it's heated, those kind of things. So we're looking at how it reacts, not what it is as a substance. So that's the difference. So here's just a mathy question on density. So a rectangular prism of carbon has sides 20 centimeters by 12 centimeters by 5 centimeters. And we know that carbon has a density of 2.3 grams per centimeter cubed. What would be the mass of the cube? So mass is simply the density of the substance times the volume that it takes up. It's the density times how much space it takes up. So let's figure out the volume first. 20 times 12 times 5 gives you 1200 centimeters cubed. So the mass would simply just be this times this, which is what we've got here, just the other way around, giving us 2,760 grams. What does that tell us? 1200 centimeters cubed, just big 1.2 liters in in terms of water, 1.2 liters, which is not very big, almost 3 kilos. You can see that having a very dense substance means that in a very small volume, we can have a lot of mass. So that's what density is all about. So graphite is an electrically conductive substance, yet we tend to expend energy to make pure copper for our electrical wiring. Why is this so? Graphite is good at conducting electricity, and it has a lot of uses as an electrical conductor. We spend a lot of time, money, and energy getting copper out of the ground. So why do we want to do this? If lots of carbon around, we can use lots of carbon for things. So why don't we just make wires out of carbon? So the reason is because copper is a metal and is very ductile. This means that it can be drawn into wires easily. So ductility means how it measures how easy it is to stretch into a wire. Additionally, the metal is malleable, which means it's not likely to fracture or snap under stress. If we had maybe a carbon wire, if a bird sat on it, maybe that's too much weight and it'll snap. Graphite does not possess these properties and thus can't be used for electrical wiring, despite its good electrical conductivity. So because it's so good at conducting electricity doesn't mean it's good in all applications where electrical conductivity is required. This is sort of the work of a material scientist, is to determine, well, what goes where and what is the best material to use for a particular application. Okay? So that concludes today's lesson on metals, nonmetals, and semimetals. We looked at each category and what the properties of each of these categories of elements are. So hopefully you've learned something about the chemicals that we see in our everyday life, and I look forward to seeing you at our next lesson.